Today we are going to study about Mendeleev's periodic table. By now we have learned about Dobernier's law of threads and Newland's law of octaves. And these laws, they could not give what was required. So they were a failure. They could not succeed. As a result, Mendeleev came up with his ideas and he postulated and he gave a periodic table which was known as Mendeleev's periodic table. Now, what he considered here, he arranged the elements on the basis of their fundamental property, the atomic mass, and on the similarity of chemical properties. Okay, so he has given one of the law. What was that? Mendeleev classification is based on atomic weight. First point that he said, atomic weight is the fundamental property. As we have discussed right now also, fundamental property. And the other thing that he states, that the physical as well as chemical properties of an element are periodic functions of their atomic weight. So these were the two bases on which it was based. Mendeleev's periodic table. Okay, so this you need to learn what was the basis of Mendeleev's periodic table. So it was atomic weight is the fundamental property, and another one was that physical and chemical properties of an element are periodic functions of their atomic weight. Okay, now what he did at that time when he started his research or his studies, at that time 63 elements were known. How many elements? 63 elements were known at that time. So what he did, he worked upon these 63 elements and he made them react in such a way with hydrogen and oxygen, and recorded his observation on the flashcards. He made flashcards and on them he wrote about the observations, and then he arranged them on a wall in such a way that they were in the reactivity order of their reactivities. So what he did, he made, when the elements reacted with hydrogen, they made hydrides, and when they reacted with oxygen, they formed oxides, the oxides of the elements and the hydrides of the elements. Now these were arranged according to their reactivity, and what was found, he found that the formulae of the hydrides and the oxides that were formed by an element, they were treated as one of the basic properties of an element for its classification. So what he did, he took 63 cards, and what did he do on those? On those 63 cards, he wrote down the properties of each element. Okay, now he sorted out them, and the elements with similar properties, and pinned the card together on a wall. Okay. Now, what did he observe? He observed that the elements which were quite reactive, okay, they were arranged in such a way on the basis of their reactivity only. On the basis of their reactivity. The ones which were more reactive and then the lesser ones. Okay. And also he found out that the elements got a place in a periodic table and were arranged automatically in the order of their increasing atomic masses also. Okay. And he also found that periodicity also occurred. Okay. Reoccurrence of periodicity was also there. Now what do you mean by periodicity? Periodicity means that after an interval they were again being repeated on the basis of their properties. Okay. So on this basis Mendeleev gave a periodic law. He gave a periodic law, and according to that periodic law, what is the statement? It states periodic law stated by Mendeleev. It states that the properties, it is an important one, the properties of an element are the periodic function of their atomic masses. This is important. You need to learn. In 1 marks it can be asked, and it is often asked also. What is Mendeleev's periodic law? Okay, so what is it? The properties of an element are the periodic function of their atomic masses. Now, he gave a periodic table which contains some vertical columns and called them groups. Okay, and some horizontal rows. And he called them periods. You can refer to the figure present in your, given in your NCERT book. Figure is 5.4. In table 5.4 you can go through. Now, what was the achievements? See, this was quite acceptable. Whatever the things he proposed, whatever the concepts he put forward, they were quite acceptable, because by that time the people, those who are working on the periodic arrangement or the arrangement of the elements in a tabulated form, out of all the concepts that were done, Mendeleev's periodic table was the most successful one. So why it was successful one? Because of some of the achievements. Now, what were the achievements according to his periodic table? He told that because of his periodic table, what was actually being put forward, the comparative studies of elements were made easier. Now, second thing, that it also showed the relationship between the elements of a group. Okay, then what else? The study means the atomic weight of some elements, just like atomic weight of some elements like gold, platinum, uranium, etc. were corrected. Okay, they were not exactly what was required, but they were corrected, because before that it was incorrect. Whatever the atomic weight was proposed, that was incorrect one. Okay, now the valency of some elements were corrected. What does it mean? Like example is beryllium. Beryllium was assumed to be trivalent. It was thought to be trivalent. Okay, but no, it was not. Actually, it was bivalent. So this also was known because of the Mendeleev's periodic table. Clear? Now, after this, what else? He also left some. The very important thing that he did was that he left some empty spaces or vacant spaces. He left vacant spaces in his periodic table so that the elements which could be discovered in future, they could be placed in those. Okay, so he left some blank spaces in his table, and examples are gallium, which was later on discovered in third group, okay, same way for germanium in fourth group, so they were unknown at that time. Fine. So they were actually given the names like Eka aluminium. Gallium was called Eka aluminium because it would share the properties similar to aluminium. So what he did, he took the prefix Eka, which derived from Sanskrit word. Same way for germanium, he gave the name Eka silicon. Okay, so why he called them? Because the elements which were discovered later on, gallium and germanium, they were found to match closely to these aluminium and silicon. Okay, so on this basis he gave the name of gallium as Eka aluminium and germanium as Eka silicon. Okay, so now what were the anomalies? Anomalies of Mendeleev's periodic table. What were the shortcomings or limitations of his table? Some elements with similar properties were placed in different groups. Placed in different groups. He did not keep them in same group. Okay, so this was a drawback of his modern periodic table. Okay, and while some with dissimilar properties were kept in same group. Two things I have told here. The elements with similar properties, they were placed in different groups, while the ones which were dissimilar, they were kept in same groups. Example, tellurium, Tellurium, okay, was placed in 6th group before iodine. No similarity at all. Okay, so they were put in dissimilar groups, while the ones which were having the similar properties, they were put in were put in different groups. Clear? Now they do not share any kind of, tellurium and iodine, they do not share any kind of similarities, but even then they were kept over there. Okay, now what was the another drawback? The another one was that he could not keep or give place to isotopes. Isotopes were not given place in his table. Okay, position of hydrogen was not clear. Not clear in his table, and he did not leave any space for lanthanoids and actinoids. Now the ones which have been given place in modern periodic table below the main table. Okay, now what else? He could not explain the concept of variable, could not explain the variable valencies. The concept of variable valencies of an element were also not explained. Okay, so these were some of the limitations which were found, or drawbacks which were not the points which were not fulfilled by Mendeleev's periodic table. Okay, so this was all about the modern periodic Mendeleev's periodic table. So learn it, revise it.